Hello, my name is Aichata Diarra, and I am a first-year undergraduate student working in a metabolic kitchen and children's eating behavior lab under Dr. Kathleen Keller. This poster presents preliminary results on an ongoing project called Project Reach. Project Reach utilizes fMRI imaging from children's exposure to food and toy commercials and responses in the reward and self-control regions of their brains. The Children's Eating Behavior Laboratory conducted an fMRI with 59 children, ages 7 to 9, to examine the influence of food marketing. Children completed a 1-hour fMRI scan to assess brain response to food versus toy commercials on neural processing of high-calorie food images, making visualizing the effects of advertisement on children possible. fMRI and MRI are both radio wave and magnetic field imaging modalities, but for different uses. MRI is primarily used for the sake of obtaining high-resolution photographs of the bodily physical structure of organs and tissues, for example, joints, spine, or brain. It records high-definition static photographs useful in diagnosing physical illnesses such as injury, tumor, or abnormalities. While fMRI tracks brain function by detecting changes in blood flow, a specific region of the brain will be more active when it needs more oxygenated blood. These changes over time are detected by fMRI. Therefore, fMRI is best used to discover how the brain functions on tasks, emotions, or senses. MRI can view anatomy, but fMRI observes the brain while it is performing. The experiment in total has 5 lab visits, but only one of those is an fMRI visit. During the fMRI, they watch commercials, and then immediately after the commercial, they use controllers to rate whether they want to eat high energy density foods such as chips, cookies, or pizza versus low energy density foods such as fruits and vegetables. They watch either food or toy commercials, with the goal of the toy commercial being equally rewarding to most kids compared to foods, and that kids will want to eat high energy density foods more after watching the food commercials. If that is true, then what part of the brain was active when they made that decision is what the fMRI should be tracking. After they do that, they play a stop signal task. As for the 4 other visits, visit 2 is the fMRI, visit 3 and 4 are identical, with no MRI, but one time they watch food ads before they eat, and one time they watch toy ads before they eat. This is demonstrated in Figure 1. The EAH paradigm, the eating in absence of hunger paradigm, is both a behavioral measure and one widely used to gauge children's eating behavior in response to external cues instead of internal hunger. After children have eaten a meal to satiety, they are provided access to varied palatable snack foods in a context manipulated to control for factors that might influence eating behavior, and a measure of their eating is taken even though they reported fullness. The measure of food intake despite fullness indicates non-homeostatic eating, and EAH has been used to access propensity to overeat and is related to exposure to food advertising, reward sensitivity, and obesity risk. Figure 5 represents what is done in the lab pertaining to the EAH paradigm. After advertising exposure, eating in the absence of hunger is measured by first having kids eat a meal to satiety. Following the meal, children are given access to a tray of sweets and snacks, as well as age-appropriate toys. The amount consumed of the snacks in 15 minutes is considered eating in the absence of hunger. Figures 2 and 3 are after advertising exposure, and Figure 4 represents the data management to retain Figures 2 and 3. Thank you so much for watching the fMRI paradigm in relation to children's food response. Thank you to Dr. Keller, and thank you to everyone in the Metabolic Kitchen and Children's Eating Behavior Lab.